In this video, we'll look at how to do derivatives and integrals of a particular inverse trig function. So the trig function that we're going to concentrate on is arctangent. And for various reasons, this is the most important of the six inverse trig functions. I won't go into the details as to why it's the most important, but I want to concentrate most heavily on it. So there are two questions we want to answer with this. One, how do you take the derivative of it? And two, how do you use it in the midst of integration problems? So we'll take the derivative question first. So the derivative of arctangent of x, and what it comes out to be is a little surprising, and I'll prove why this is the case in class, but for right now we'll just take it on faith. The integral of arctangent is 1 over 1 plus x squared. Okay, so in dealing with this, you might still have to use the product rule or chain rule or so on. So for example, if we want to do the derivative of arctangent of 3x, this would be 1 over 1 plus 3x squared times 3. Now, why are these things, everything here the way it is? We're taking the derivative of arctangent of some stuff, and that's going to be 1 over 1 plus the stuff squared, and then by the chain rule, I have to multiply by the derivative of the stuff. Chain rule. Okay, so the derivative of 3x is 3. That was sort of my insides here, and I have to multiply by that derivative by the chain rule. Okay, and so if I had something like x arctan of 3x, then now I have to use the product rule too, and so I get the first thing times the derivative of the second, which we already said was this, 3x squared times 3, plus the second times the derivative of the first. So the derivative of x is 1, and then the arctangent just comes along for the ride. And that's it. So the derivative direction is not too difficult. We just have to remember to obey the chain rule or product rule or whatever is the case. So next let's look at integrals. And the example that I want to kind of work with is we'll take something like 16 over 1 plus 4x squared. Now, the mistake answer here is to assume that the answer is going to have something to do with logarithms because we have a fraction. That's unfortunately not true. If this were just x in the denominator, then we could do a u substitution and it would involve logarithms, but the x squared changes things. So what I want to do is start to rewrite this a little bit. The first thing is, let's just get rid of that 16, and I'm going to just have a dx on top. And then in the denominator, I'm going to think of 4x squared as really being 2x squared. So you may kind of start to see where I'm going with this. I'm going to make this thing look kind of like this derivative did here. Now, I can't quite do this just yet because, like in this problem, we had a 3x on the inside and also a 3 on top. In this problem, we've got a 2x on the inside, but there's no 2 there. So what I'm going to do is the standard trick of let's put a 2 in and take a 2 out. So, of course, 16 over 2 is 8, and so now I've got 2 dx over 1 plus 2x squared. And so what that means is I can make a u substitution. And so I'll let, let's see, we'll use blue for this. We'll let u equal 2x, du is 2x, or sorry, 2dx. And if I go ahead and make the substitution, then the 2dx, this guy is right there, and then this guy is right there. So this thing is actually du over 1 plus u squared. And that looks a whole lot like this here. It's just I've got u's instead of x's. So this is just 8 from the 8 out front. And then the integral here is arctan of u. And of course we need a plus c, just for fun. And then in order to finish this, we have to remember, well, what was u? And the substitution tells us that answer. It was 2x, that was our choice. And so we get 8 arctangent of 2x. And we could, of course, check our answer by taking the derivative of this. And if we get back to the 16 over the stuff here, then we've, in fact, done it correctly. And just like over here, this looks kind of like that. Okay, so in class, we'll look at briefly how you work with the other 5 inverse trig functions. But for the takeaway for now is that arctangent is important. So this is something I want you guys to memorize. And the integration version of it is that the integral of dx over 1 plus x squared is arctan of x plus c.